Today we're going to talk about chemical bonds. First of all, you need to understand there are two types of chemical bonds when it comes to forming compounds. Those are ionic bonds and covalent bonds. As the name says, ionic bonds involve ions. The positive metal ion attracted to usually a negative non-metal ion. Sometimes other ions called polyatomic ions are involved, but again, they have a positive or a negative charge, and the opposites attract, and they form structures known as crystal lattices. The other type of bonds are covalent bonds. These types of bonds are formed when electrons share their single valence electrons. This is why it's important to know how the structure of the valence electrons is established in any element. These types of compounds are referred to as molecular compounds. Water would be one example. Making a chemical bond is always exothermic. That means every time elements come together to form a compound, and make a bond, energy is released. This is because, remember, elements are unstable chemically. They don't have 8 valence electrons. They don't have a full outer shell. And so they're looking to react to fill that outer shell. They do so by forming chemical bonds. The chemical bonds makes them more chemically stable. So that unstable energy that they possess when they're not bonded is released into the surroundings when the bond forms. Breaking a bond is the opposite. Just like breaking a pencil takes some energy, breaking a chemical bond takes energy. So it's an endothermic process. Different bonds have different strengths. So the stronger the bond that you're trying to break, obviously the more energy it's going to take to break it. The opposite is also true. When two elements come together and form a very strong bond between them, a lot of energy is released in the process. So in a chemical reaction, there's both processes happening. Sometimes chemical bonds have to be broken, new chemical bonds have to be made, because remember, in a chemical change, atoms are rearranged to form new substances, but we're just changing the chemical bonds that exist, and that's how we get different properties, different substances. So energy is used in parts of the reaction to break bonds, energy is released in other parts of the reaction as new bonds are made. So overall, a reaction can end up exothermic or endothermic depending on the number and types of bonds that are broken and the number and types of bonds that are made in the process. Now, I've mentioned that these bonds that involve the formation of compounds are either ionic or covalent. There are other types of bonds, but they never are involved in the formation of compounds. Some of these bonds, and you may have heard of a few, are metallic bonds, which exist when metal atoms interact with each other, for instance, in an alloy, which is not a compound, but a mixture. Or hydrogen bonds, which you might remember from biology class. They are found between water molecules, also between water and other molecules as water interacts with other substances, and also found in the DNA molecule, which helps it keep its double helix form. So chemical bonds involve valence electrons. Atoms can either transfer, meaning gaining or losing valence electrons from one to the other, or they can share valence electrons as a compound forms. In an ionic bond, the electrons are transferred. Typically, this transfer happens from a metal because metals have few valence electrons and like to lose them, forming positive ions. And then those valence electrons get picked up by a nonmetal, okay, which wants to add to its valence, and that forms a negative ion. And as we know, when you have charged particles, opposites attract. Positive ions will be attracted to negative ions. That's known as an ionic bond. In covalent bonds, again, electrons are shared. Specifically, again, the single valence electrons are shared. So again, you do have to know whether the electrons are paired in the orbital or single. Okay, again, it is those single electrons that are shared. Again, this type of bond typically happens when one nonmetal bonds to another nonmetal. And there are many compounds like that, like water, carbon dioxide, nitrogen gas, which makes up the air for the most part. Okay, so many different compounds like that. For ionic bonds, again, we get positive and negative ions. If you start with a neutral atom, okay, which means, again, the number of protons is equal to its number of electrons. Anything other than a noble gas, again, does not have a full valence shell and is looking to either lose electrons or gain electrons to get to that complete octet. So metals, which have few valence electrons, tend to form positive cations by losing electrons, and nonmetals, which have more valence electrons and are closer to 8, tend to add to their valence and become negative anions. Again, when they do form ions, a metal and a nonmetal often attract one another because they are opposite in charge. This force of attraction that brings opposite charged ions together is known as electrostatic force. This is also the same force that produces static cling when clothes comes out of the dryer, or maybe as you pull on a sweater or something and your hair sticks up. And it's also the same force that produces lightning. So yes, it is a very strong force if enough electrons are involved. One example is sodium chloride. Sodium, again, has one valence electron. It is an alkali metal. They all have one valence electron. Again, sodium, when it reacts, will lose that valence electron and become a positive sodium ion, as shown right here. Chlorine, on the other hand, again, is a halogen and has 7 valence electrons. So chlorine is looking to add an electron. So this free electron, which came from sodium, gets added to chlorine, and we get a negative chloride ion. So again, opposites will attract one another. Okay, that's known as electrostatic force. When they do, we get the compound known as sodium chloride. Okay, now there's a bond between the sodium and the chlorine. The positive and negative charges cancel each other out, and we have a neutral compound. Again, we just made a new chemical bond, so energy is released in this process, as this video will show you.
Sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame.
So there you can see a lot of light energy. You can imagine it's also hot, as the chlorine, which again is the yellowish gas in the container, and the sodium metal, which was silvery and just heated to the point where it was warmed up, almost melting, are now reacting and forming a compound.
It produces a white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride. Afterwards, the glass spoon contains only white solid sodium chloride.
So there's sodium chloride, again, also known as table salt, where it used to be, again, a silvery metal, okay, is now a compound of sodium and chlorine. Again, properties have changed, a new compound has formed, and energy was released in the process. Covalent bonds, again, involve the sharing of electrons. There's Equal sharing and unequal sharing in terms of elements and their valence electrons. When the electrons are shared equally between the two atoms, it's known as a non-polar bond, because a pole, like north-south or positive-negative on a magnet, are opposites. Okay, so non-polar means no poles. When electrons are shared equally, there is no difference in charge between the two sides of the bond. A polar bond, okay, results when the electrons are not shared equally. I like to describe it as one atom hogging the electrons, and again, electrons are negative, so that side of the bond is more negative. There are certain elements that are considered sort of electron hogs because of a property known as electronegativity, and we'll talk about them in just a moment. So here's an example of a covalent bond. Okay, we have the nonmetal nitrogen. Okay, nitrogen has 5 valence electrons. 2 of them are paired. Okay, then there are 3 single. So nitrogen wants to share 3 valence electrons. It forms a compound with iodine. Iodine again is a halogen, so they have 7 total valence electrons. Only 1 is single. So in order to form a compound between nitrogen and iodine, we need 3 iodine, okay, so that all of the valence electrons, all the single valence electrons of nitrogen are used up. So as you can see in the diagram here, the electrons circled in red indicate electrons that are shared. So these 2 electrons, one from nitrogen and one from iodine, are shared between the nitrogen and this iodine. Okay, that's known as a covalent bond. There's another covalent bond over here and a third covalent bond here. So again, we're making new bonds and energy is released when this compound forms. So this property of electronegativity, which I was describing earlier, has to do with how well an atom attracts electrons to itself when it bonds with other atoms. Okay? Metals tend to have low electronegativity because they don't want additional electrons. In fact, they prefer to lose valence electrons. And nonmetals, with the exception of the noble gases that again are already stable and don't form compounds, tend to have higher electronegativities. Elements like fluorine, oxygen, nitrogen, and sulfur in particular have high electronegativities and tend to hog electrons when they are bonded to other nonmetals. So the type of bond that you get depends on the electronegativity difference between the elements. So you need to know the electronegativity values, and you look at the difference, which means you subtract to see what type of bond will form. The 3 categories, of course, are ionic, meaning that electrons aren't shared at all, okay, but they're transferred. You have nonpolar covalent, where the electrons are shared equally between the 2 atoms because their electronegativities are fairly equal. Or polar covalent, meaning the electrons are shared, but again, one element kind of hogs the electrons more than the other, creating sort of a negative side to the bond. That is where we are going to stop in this session. We will continue with more notes at another time.